Problem 10.61. Suppose we have a random sample following the gamma distribution with alpha is equal to 1, alpha equal to 2, and the beta is the parameter to be estimated. Then find the maximum likelihood estimate of beta. So first, we write down the likelihood function of beta. So likelihood function of beta is just the joint distribution of the random sample with this beta as the unknown parameter. So the x will be given, and this beta will be the parameter to be estimated. Then because these things are independent and identically distributed, so the joint distribution is just the product of the marginal distribution, or just the product of their individual distributions here. And we call that the individual distribution for the gamma distribution. The gamma random variable is given by that. Okay, it's the gamma function of 2 times the beta square times x to the power alpha minus 1, where alpha is equal to 2 here, and e to the negative x over beta. Some books use 1 over beta instead of beta. So in those cases, the beta will be on the numerator, and also this beta will be on the numerator. Okay, but either way, you get the same type of maximum likelihood estimator, because we know that maximum likelihood estimate is invariant. Okay, so now, so simplifying this, we get that the distribution for each random sample is following this form. So we're just going to plug in that with x replaced with xi. So that will be your likelihood function. But to find the maximizer, we usually take the logarithm. Natural log will be fine to this function. So by plugging this in here and take a logarithm, we'll get this. Okay, so now to find the maximizer, we just take the derivative of this, set it to 0, solve for the critical point. So take the derivative of this term is gone, and this we have 1 over beta square times this. So that becomes this by taking the derivative, and also this by taking the derivative with respect to beta, we have that. And set it to 0 and solve for beta, and the beta it turns out to be this, which is just a half of the sample mean. Okay, and so our maximum likelihood estimator will be the half of the sample mean. And it's not surprising actually, because the sample mean, the mean of this distribution is actually 2 times beta. So, or in other words, beta equals to the mean divided by 2. And now our estimator for beta is just the sample mean divided by 2.